Hello everyone, welcome. Today we are diving into the world of IoT using a NodeMCU ESP8266 and a powerful cloud platform called ThingSpeak. By the end of this video, you will be able to send live data from your NodeMCU directly to the cloud and view it in real time. Let's start. Welcome to Cocowatt Media. Let's begin by setting up ThingSpeak, which is an open source IoT platform from MathWorks. It allows us to collect, store, and visualize sensor data from IoT devices. Head over to thingspeak.com. If you are new, you have to press on Create User. You will be directed to a MathWorks account page. That is because ThingSpeak is managed by MathWorks. Go ahead and create your account. Here you have to give your email address. After that, you can select your country. Once you selected the country, then you give your first name. After that, last name. Go ahead. In the next page, you have to give your email ID and you have to give the consent for MathWorks. Press on continue. There will be a verification mail on your email. Please check it. And now you have to verify your account through this email. Once profile is verified, select your country. Now go back to the previous ThingSpeak site. Here, press on continue. Now you have to set your password for the ThingSpeak account. The password should contain at least one capital letter, one small letter, and a number. Once your account is ready, log into ThingSpeak. First time when logging, it will ask for a few questions. It will ask what is our intent of usage. In my case, it is for research in IoT, and I will give my company name, Cocowatt, and a current role is researcher. What is the name of your course of project? It's IoT for all. Okay. You will land on your dashboard, which gives you access to your channels. In your channel, you can see there are many example projects already, which is Arduino based ESP8266, Raspberry Pi, etc. So to create a new channel, here click on the new channel. You can give any name for your channel. I'm just giving members count. You can count people entered in a room, and that number you can update in your dashboard. And in the field 1 is the area where the data will get updated. You can give any name, count, or crowd, any variable name which is meaningful for you, you can give here. Description is not mandatory, but I'm just giving some description. Now scroll down and press on Save Channel. So the channel is created here. Now once the data is uploaded to the server, that will be charted here. As per the sharing option, the data can be in private view or public view. Your channel settings will be here, and as you told, the sharing option you can change here. Now the important part, API keys. In the API keys tab, you can see a write API key and a read API keys. These are the keys used to authenticate when you are trying to access the server address for writing or reading a particular field. You can see the separate API request here for writing the channel and reading the channel. When you see this address, there is a server address part and there is an API key, and the last part is the field or the data which you want to update. We will copy these API keys in a separate notepad so that can be used in our programming. So in second part of this tutor video, we are going to program our NodeMCU ESP8266 using Arduino IDE. So we will start Arduino IDE. we are going to write Arduino based programming. I hope you will be knowing the basics of Arduino programming. There is a setup part and there is a loop part. And if you're new to the Arduino programming, we can discuss in detail about Arduino programming in another video. So now let's continue. We will start by including two important libraries, Wi-Fi.h and HTTP client.h. Since we are using ESP8266 board, it's 8266 Wi-Fi.h and ESP8266 HTTP client.h. So we are communicating with ThingSpeak using HTTP GET method. Now, next we have to define our Wi-Fi credentials. So SSID is your user name and password. So replace the double quotes with your own network name and password. We also set up our ThingSpeak API key next. You will find this key in your ThingSpeak channel settings. We already discussed this. Then we define the ThingSpeak server URL as it is. Here, one important point we have to note is our NodeMCU will not support HTTPS security protocol. It will support only HTTP. So we have to replace this S here. And now inside the setup function, we start the serial monitor with serial begin and we specify the baud rate. So this is the baud rate which we are using to communicate. We can debug and see output messages using this. Then we connect to Wi-Fi using Wi-Fi begin and the arguments are the SSID and password which we already specified on top. We also add a loop that keeps trying until the Wi-Fi is connected. Once it is connected, we print the local IP address for confirmation here. Now the main part is inside the loop function. So we will create two objects, Wi-Fi client and HTTP client. Then we increment a random variable and we try to send this variable to the server. Say it simulates reading a new data from a sensor. We haven't declared this variable, so we will declare this variable on top. Next, we build the full URL using our API key and data value. For example, it will look something like this. This tells the ThingSpeak to store some random variable as the value of field 1. Then we begin the HTTP connection using HTTP begin and make a GET request with HTTP GET. If the request is successful, we print the HTTP response code. A response code of 200 means it's success. If the request fails, we print the error code instead. Finally, we add a delay of 30 seconds using delay function. This means the data will be sent to ThingSpeak in every 30 seconds. We are using a free account in ThingSpeak, so we have a restriction for updating data. It will be updated only in 15 to 17 seconds exactly, I'm not sure. Now let us save our Arduino sketch. Just go to file and save sketches. Once this is saved, now we can compile. To compile, you can use this button. We'll wait for compilation. Oh wow, one error. What is that? Wi-Fi. When we created the object for Wi-Fi client, we used the wrong class name. It's Wi-Fi client is the class name. So we'll correct it and we will try to compile again. Yeah, now this time it's successful. Now next we have to connect our NodeMCU board with our PC. So this is our NodeMCU. We will connect this NodeMCU to our computer using USB. NodeMCU is once successfully connected with the computer. You can see it here, it is connected. Now we can build using this button. We can just click on this. It will compile again and start uploading to your NodeMCU. So to just wait for, it's successfully flashed. Now to see the outputs, we can open the serial monitor and I'm just resetting. So you can see it is connecting and we can monitor whether the data is updating in ThingSpeak or not. See here, 1 is updated first, 2 is also updated because some program already running in this ThingSpeak. After that, 1 is updated. We can see our serial monitor. Yeah, we updated first 1, then 2. Let's see whether next data 3 is updating properly or not. Let's go back to ThingSpeak and see. Yeah, see, it's 3 is also updated. So this is how the data is updated from an edge. That means from your NodeMCU to a cloud. Here it's ThingSpeak. If you enjoyed this tutorial, please give it a thumbs up, share it with your friends, and subscribe for more IoT and embedded projects. Thank you. Thanks for watching.